Hi, welcome at this session on modernizing your VCL application. My name is Danny Wind and I work for the Delphi company in the Netherlands. I'm a Delphi trainer, consultant and Delphi MVP, and my favorite subjects are FireMonkey, user interfaces and threading. The elements of this session are freshening up the VCL look and feel with styling, font and controls, adding a tile-based dashboard into an existing VCL application, and to speed up responsiveness and overall performance using a TTask with asynchronous queries as well as Interbase Change Views. We'll start with a fresh look. The existing application has Windows XP, Windows 7 styling, and we're going to use a modern style for the entire application. We'll also change the font. The default font of a VCL application is Tahoma 8 points. We're going to change that to Sigu UI 9 points or larger, depending on the target screen sizes of your customers. We'll also add some modern controls. These modern controls in the Windows 10 tab will have animation effect and tactile feedback, and will give your users the idea and the feeling that they're in control of your application. It's also easy to do search and replace fonts and controls. You can use Ultra Edit scripting or even the Refine tool that's bundled in Delphi itself. We'll use the modern Windows 10 styles that are integrated in Delphi, but you can also use commercial modern styles, for instance at delphistyles.com. These modern styles also style the common dialogues. The modern VCL controls that we'll be using are the calendar picker and the search box. And the calendar picker has a nice animation up and down with the month selection and year selections. We'll also use the split view for the new style menu, as well as an activity indicator for background processing. And the split view looks a bit like this. You can display a menu on the left hand side with icons as well as text. And the search box allows you to display either searching with a keyboard or searching from Cortana. Okay, let's take a look at the existing Webshop application, the Webshop BackOffice. It's an old style application. It has a backend with an Interbase database with 1 million records in it. After it's compiled, it'll run, but it will take a while to start up. In the meantime, we can change the appearance using project options and then going to appearance. We can actually preview the new appearances. So let's preview Windows 10 Blue. It looks like that. Or Windows 10 Gray, which looks like that. End users will probably relate easier to Windows 10 Gray. So you could use that if you want to. It took 23 seconds to actually load the 1 million records, and it's this basic application with orders and customers and employees, and you can enter a new order for a customer. The calendar is still the old style calendar, no animation there, old icons as well, and of course the print dialog is unstyled as well. The icons here, we need to replace those as well, and the menu, we're going to append the menu with a split view. First, let's change the font of the main form. Because the old font, Tahoma, it sort of screams out Windows XP. So just change that to Sigu UI. And you can use 9 points here, which is the default for Windows 10. Or, if you prefer, you can make it even slightly larger. Why would you make it slightly larger? That has to do with high DPI screens, where the scaling doesn't always work well in Windows 10. Okay, let's find out how this looks. And we'll be seeing the Windows 10 Blue style in the splash screen already. Keep in mind you could also use the Windows 10 Gray style. It's less obviously visibly styled, but it will still have the Windows 10 style controls. Okay, one of the things we see here that the orders, customers and employees, it's all styled now. Even the dialogues are styled, so the print dialog is styled as well. I haven't changed the calendar yet, but you'll see that the buttons for the dataset have been styled. And if you look at the new order screen, that's styled as well. And changing the font to Sigu UI makes the app look modern instead of dated when you're using Tahoma. Next up is adding a Windows 10 style side menu. It's called the split view. It needs a panel to be able to scroll the other components and controls on your main screen to the right hand side. So that panel, let's name it panel main. It will be the main panel that will have the toolbar and all the page controls that are inside the application. Let's align that to client. So that looks the same. If we add a split view, that split view will be left aligned. And let's put the split view on the main level, so it's the highest level. And that split view needs to have some buttons for the menu. So that's a category buttons control. Category buttons allows you to create nested buttons with icons and text, ideally suited for a Windows 10 split view. For the split view category buttons, we don't want to use the old icons, we want to use some new ones. I've got some new ones here. They're 32 pixels by 32 pixels large. And let's add them from the images directory here. Those icons are actually default icons available in Windows 10. Okay. Let's change the toolbar a little higher. So we've got place for the larger icons. Let's remove everything here. Because instead of a toolbar, we'll now have a left-hand side split view that will have all the buttons, except one, which we'll be using to return back to a full screen after we've opened the split view. Okay, let's link that. We're going to create a couple of actions, action main as well as action home. The main action will actually open the split view and the home action will close it. Let's change this one to icon 2 because that's the correct icon for the print dialog. And let me see here, the search, that should be 4, oh no, 3, yeah. And this one's 4 already, okay, so that's okay, that looks good. Let's add another one, action settings, and let's use icon 5, which is the cogwheel for that one. Okay, looks good. Okay, let's take a look at the category buttons. Category buttons is actually like a menu. We're going to increase the size a bit to a button height of 40 and a little bit more width, 100 is okay. And set some options. The options actually determine how the buttons are visualized. You should take a look at all these options. So we're going to use full size and caption, only border, and show captions. So that's good. In the categories editor, you can add the main menu items, like in the normal menu, that would be file. By setting the color to CL none, I'm making sure that it's transparent. And in the items editor, you can add the submenu items. So under file, you would have open and close and exit. Here I'm going to add 4 button items, and the first one will be connected to the action home. The next one, let's take the print dialog, and the other one, let's connect that to, let's take contents for the help, and the last one, let's use settings. Okay. The actions, the main and home, I hadn't actually coded them yet, so in the main execute, what I'm going to do is I'm going to open the split view when it's not already open. So if split view is opened, then I'm going to close it, and if not, I'll just open it. Same thing for the home action, but the home action should make sure that the split view is closed. So just the top here, if split view open, then close it, so we can get our main screen back. The split view is now opened, so we need to close it in design time. It's opened is false. As you know, Delphi is positive in properties. And the main button, we hadn't connected that one to the action main yet, so let's do that. And let's take a look. And while it's compiling and linking and starting up, the split view is actually something that you can add next to the existing menu. So you could keep the existing menu intact and just move some items like home or print from the main menu down to the split view menu. Or you could just put functionality there and use the main menu for nitty-gritty stuff. Orders, customers, employees, it's all looking good, and except this one. This one's still old style, doesn't animate, doesn't do much. So we're going to change that one into a calendar picker, which is more in the Windows 10 style. Now I'm doing this manually, but you'd probably use Ultra Edit, scripting, or something like refind for a regular expression find replace. Okay, but I'm going to do manual calendar picker here. Let's align this a little so that it looks good, and then use the onChange event handler from the previous calendar component. It's in onChange. That's a datetime picker. Change. Okay, instead of a datetime picker, now we have a calendar picker. Sort of works the same though. So that's all we need to change. In the customer tab, I'm going to use a search box. And I'm going to use the search box so the user can type in a customer that he wants to find. The search box itself has a number of display capabilities. One of them is displaying a search glass, an hourglass. That's not really an hourglass, of course, it's the magnifier glass. And instead of having an onChange, you have an onInvoke search. That's called if the user actually invokes a search by pressing enter or touching the magnifier glass. So we're going to use the data module find customer to find the customer that the user just put into the search box. And it's just a search box text. Okay. Let's see how this works. Startup's going to take a little while, so let's skip ahead and try to find a customer. For instance, Dawn. There we've got Dawn and Martin. And in orders, I'm going to select the date. As you can see, you've got animation from month to month. And if you click on the month, you can actually select the month, and then you get animations back and forth, even for the years. And that's kind of what we need to make our application look modern and Windows 10 alike. If you don't like the Windows 10 look, take a look at what FL Studio did with their FireMonkey Delphi application, or take a look at Adobe Dreamweaver, which are both Delphi applications. Next up, we're going to create a dashboard. It creates an overview of what's important. It allows you to jump into to-do items and will streamline your application so the end user can actually start working at the moment the application starts. As a preparation for this demo, I've created some frames. And a frame is essentially just a form without a border, or a component template if you will. And these frames, in this case, they have the exact measurements that I want from my tiles. So they're sort of square with the possibility to add an image on the top with an item title and item subtitle. And I've created one with an image on top as well in the chart. So I've got several versions of this frame, and they're all derived from the basic unit frame tile. Now the source code for this application is available as a separate download at the end of this CodeRage session. So don't worry, you'll be able to see how these frames work. I'm going to create a new form dashboard, and that form dashboard will be our main form. And that main form will start before the current main form. So we need to modify that form dashboard as the primary form. And then we'll add the templates, the tile templates. Actually, I've added these templates by using a right-click add to template. So they're easily available in the Delphi IDE. If you're going to use that, also just right-click on the template and add to palette, and you'll be able to use the frames like I'm doing right here. First frame, it will be the new orders frame. Let's display all orders instead of new orders. So let's make this tile orders, all as a title. And the same tile orders here. Orders all. In the actual application, you'd probably add some nice graphics. And you could even include the basic information of the orders that are detected to be new orders. In this case, this is the new orders. So using change views, which we'll do later on, you could request the new orders, and that would only take a very short amount of time to request those new orders. And you could display them here. And if the user clicks on the new orders tile, you'd be able to display only those new orders. And that would give the user an advantage in using the application. The chart template is just there for show. You could add some event handlers based on the place in which you click in the chart. So if you create a chart with months of data, you could click on January and then display just the orders or customers that were added in January. I'm just going to display all customers using the tile below here. While I connect these tiles to the main form, let's discuss the benefits of using a dashboard. The dashboard will give the user insight in what's happening with your data inside the application. You could just visualize the new orders or new customers added by different users and display those in the dashboard, so the user would have the dashboard open at all times. You just glance at the screen and see what's changed and act upon that, instead of having to actively request which orders are new, which customers have been added or changed, or is there anything I need to do. The dashboard will actually tell the user what he needs to do, and making it a lot easier for the end user to use the application. And you could add the dashboard in front of an existing application and just use it as such. And the same way I'm using it here actually. So I'm just adding it in front of an application, and that's not modifying the rest of the application. I'm just doing the same thing over and over again. Okay, action home here. I'm going to do a hide so we can go from the main form back to the dashboard instead of just closing the split view. Let's see how this looks and run it. Now I'm going to speed it up again, so I'm going to skip ahead a little here. Yep, skipped ahead. Just display all orders. You can see that the startup time is actually 30 seconds, so let's tackle that in the next session. And customers, actions still work, it's all the same. And you can add an action based on the chart or the chart bar you're in. Next, we're going to tackle the speed with which the application starts. Instead of having the user wait for 30 seconds, we'll do all that stuff in the background with asynchronous queries or using a TTask. Then we'll tackle some actual speed improvements, improving SQL performance or improving code performance. For the SQL performance, we're going to use change views. For the code performance, well, we'll see if we've got time for that from this session. When you're doing things in the background, it's nice to let the user know that something's happening. You can use the new activity indicator for that. As you may notice, if you put an activity indicator on your form and you're actually doing busy stuff in the foreground thread, the activity indicator will halt. So it's actually just usable for background activity. And using background activity, the easiest way of doing that is using the parallel programming library. It may seem challenging at first, but please take a look at my earlier session on the parallel programming library with the link that's shown on this slide, and you'll see that it's quite easy to use. Just remember to use a simple TTask as a delegation of a task. So you can just put a task that you want to delegate to someone else, in this case a TTask, inside the TTask, and then at the end of that synchronize or queue back to the main thread. If you do TTask and parallel programming in that way, you'll see that it's a lot easier to use. And if you're not using the FireDAC just yet, consider changing over to FireDAC. If you're already using FireDAC, well, that's cool. In that case, you can use advanced features like ArrayDML or asynchronous execution. FireDAC asynchronous execution is the same as using a TTask, but it's just executing the query in an asynchronous fashion. And the ArrayDML It will allow you to bundle statements, inserts and updates into one chunk that's sent to the database. If the database supports it, it's just a lot faster than just running multiple insert or updates queries sequentially. Okay, let's add a method to load the data asynchronously using FireDAC Async SQL. I'm going to call that load data async. And this procedure will kick off the asynchronous queries sequentially, actually, because a synchronous query cannot run together with another asynchronous query over one connection. It's actually blocking a connection. So let's start with the FireDAC connection Webshop connected is true, and then make sure that the queries themselves, they're run asynchronously. So we start with the FD query order status resource options and command exec mode and set that to AM async to make sure that the query order status is run asynchronously. And we'll be doing that for the other queries as well. So next one is employee, and the other one, the next one from that, that's customer, and the last one that has 1 million records is the query orders. Okay. Let's kick off starting these asynchronous queries with the first one, which is the query order status. And in the after open of the query order status, I'll be kicking off the FD query employee open. This makes sure that only one asynchronous query is running over the same connection. Of course, you could add 4 connections for these 4 queries. So you could actually execute them at the same time. That would be of some benefit here, not that much, because the largest query, the orders query, is actually taking up most of the time, and the others are much shorter. So there's not much profit in actually opening 4 connections in this case. But it may be possible for your case that you have 2 running queries that both take 15 seconds. Just open 2 connections and run both asynchronously, so both don't block the main thread. So let's open with the first one, the query order status after open. The second one is the employee, the third one is customer, and the fourth one is the orders. And this one will kick off the employee open. And that one will kick off the customer open. And after the customer opens, we open the query orders. And as soon as query orders is opened, we'll enable the user interface in the main form. Now there are much better ways of opening stuff in the main form, because now we've got a dependency between the data module and the main form, which we actually don't want. But since I'm going to improve on this using TTasks a little bit later on, I'll just do this the easy way with a direct link to the form main. And a little later on I'll just change it to a TTask with a callback, so that's much nicer code, and then you don't have the dependency between the main form and the data module. It was actually bad coding. But for the demonstration, it'll work, and it'll show you how the asynchronous queries work, and that's actually a quite nice feature. Let's disable those data sources on the main form as well. So let's go to the main form. And in the onCreate, there's the splash form still there. We no longer need that because the execution of the asynchronous queries that will take place in the background, so there's no need to update the splash screen with the progress bar after each query. The connection is also in the load data async, so we can remove that. Now let's remove everything here and just disable the data sources. And after that, just call load data async. Now the splash screen will be displayed very briefly in this case, so we may actually just dispense with it. So there's no splash screen and we don't actually need it anymore. But for now I'm just leaving it here, and you'll see that it will disappear quite fast. So the data module main load data async. After that the splash form closes. Let's take a look how this works out. Now there's no need to speed anything up anymore. This is the actual speed of the application now. It's just click and it's there. That means that the end user can actually add a new customer, because the new customer is independent of loading all the other data. Well, it's still not there, so just let's add another customer, or we can wait a little while and to see that the orders will actually display. Yeah, there they are. So these are the orders, these are the customers and employees. They've been loaded in the background and then displayed. Okay, so let's take a look at what we did. We created a load data async, and in that we set the resource options to AM async, and then we executed or opened these queries in order. First we opened the order status, then after that one employee, customer and orders, and at the end we enabled the data sources. So the user would see the new data. Now, this is all fine, of course, and this works. You could even make it better with a T-list with the asynchronous queries to open. But I kind of prefer using the parallel programming library with systems.threading, because the code that you could write from using a TTask is a lot easier to read and a lot easier to create as well. So let's do that. Let's go and add a TTask.run with an anonymous procedure. And inside that anonymous procedure, we'll just open those queries in the correct order. So we'll not be using async mode, but we'll just open the regular queries. So we can just copy this and modify it so that we open the query instead of setting it to the async mode. So just have the query order status, set active to true, and do that for the other ones as well. As you can see, it's quite easy to read here what's happening. We're just opening those queries in the correct order. And at the end, if the task is completed and the task is run asynchronously, so it's run in the background, we need to feedback that stuff to the main thread. And in the main thread, what we want to do here is to enable the data sources actually. So let's use a queue here, and the queue will ask the main thread to execute this anonymous procedure here if it has the time. And in that queue, we're going to use a callback routine, and that callback routine will be written in the main thread. So we'll have a callback into the main thread, which is a simple notify event, and that notify event is just a procedure. So let's put it here as well. And the feedback from the TTask, it's just calling the callback routine. So if it's assigned, if a callback is assigned, and we're ready with this task, just call back. This is a setup that I tend to use with using the tasks. It makes it a lot easier to code a task. It creates clean code and very readable code. The after opens, we can delete those. We don't need them anymore. So just remove those from here. And then switch over to the main form for the load data async call there. So in the unit form main, the load data async call, we are going to create a callback function here, or procedure. And that procedure callback, what it will contain is just the enablement of the data sources. So the callback will just feed back the result of executing the task to the main form, and in that to the main thread. So in that callback, What we have here is just the data source orders enabled to true, and the same for the other data sources. So data source employee, enable that to true, and set data source customer to true as well. So at the end of the TTask, it will display the results in the user interface by calling the callback routine that's in the form main. And with this callback routine, we also have independence between the data module main and the form main, because the form main will just call the callback using the callback that's executed in the main thread and actually implemented in the form main. For some feedback to the end user, I'm placing an activity indicator here. The activity indicator will show the end user that in the background there's actually something running. So the application's working, getting the orders and getting the customer data. In the callback routine, I'll just disable the activity indicator because then we're finished. So that's the end of the callback, that's the end of the task. And we need to make sure that we enable that just before actually calling the data async. So instead of a splash screen, we'll be using an activity indicator. Because the splash screen, as we saw that earlier, it doesn't actually display anymore because everything's so fast. So we can just remove the splash screen here. Let's take a look and run the application. There's no speeding up anymore, so it's there. Form dashboard. You can open orders. You can see it's running in the background with the activity indicator. The end user can still add new orders because that's independent of loading the data. The user has a fully responsive user interface, so he can just do what he likes. And in the background, stuff is just being loaded, and it's now loaded, so it's there. So that's how this works. And the end user is no longer blocked from doing stuff. It's already there. So it's a better user experience overall. To further improve the user experience, you could consider moving your application from saving data to persisting state. And persisting state means that the application always auto-saves the last changes of the user, but it also provides the user with an infinite undo or limited undo. There's some mechanisms in place in the new Delphi versions that make it easier for you to do that. For instance, using FDMEM tables that you can save to file for state persistence, using them on a local cache. But there's also the Interbase Change Views that you can use to refresh data from the database. So it's a lot easier to let the user see what's changed recently. Those state techniques, saving states, if you're using FDMEM table, make sure that you're encrypting your local storage using Lockbox. It's quite easy to do because it's just 3 or 4 lines of code. And if you're requesting changes, make sure those queries are efficient. So if you're using Interbase Change Views, that's a given. I mean, that's very fast. And we'll take a look at those Interbase Change Views in the demo. Interbase Change Views, they actually keep track of what's changed since your last query. It's using a transaction-based approach. So as soon as you activate a subscription, you'll see what's changed up until that start of the subscription. And if you commit, and then activate the subscription again, you'll see the changes between that last commit and the current active subscription. So you'll see all changes since then. And you can collect those changes and merge them with local data using the FDMEM table. There are some other improvements they can do to modernize your VCL application. Make sure that your application is active, not passive. Make sure that your dashboard is actually showing relevant data and continuously updating that relevant data. So new orders, there are 46 new orders, there are now 47 new orders. You need to process this. There's something to do here. That's for active. That means that your application is active and it's enabling your user to do their work. And the application should always be responsive. It should always have immediate feedback. So if the user clicks something, it should be doing stuff immediately and just asking the user to wait with a hourglass that's not good. So you should remove all hourglasses and remove them and change them over to activity indicators and do stuff in the background. Another option you have is integrating touch and gestures. It's quite easy to do that. Just add the gesture manager and you're good to go. Some users actually have touch screens now, and some users actually are using servers like tablets and notebooks. So they sort of want your application to have touch. So that's a good thing to add as well. Let's take a look at change views and how that works. So I'm going in the database, the Webshop database, I'm going to create a change view. And that's called a subscription. So I'm going to subscribe to changes in the orders table. So creating that subscription, create subscription for the orders table, sub orders on the orders table. A simple subscription like this, it's only subscribing to incident updates. You can also subscribe to deletes if you want to. We'll do that later on. But this the subscription for the insert and update only on the orders table. So there's no delete here. Okay, create that one. After creating the subscription, it's there. As soon as you now activate it, it will display all changes since the last commit for an active subscription. Let's do the necessary changes in the Webshop BackOffice. In the unit data main, if you're using subscriptions, you need to add a transaction component, because that allows you to start a subscription, or well, not start it, but activate a subscription. Look at the deltas since the last commit, and then decide whether or not you want to commit or roll back. If you commit at that point, and then again activate the subscription, the changes that you had in the last subscription, the delta you had in the last one, they will be committed and they'll be gone. And you'll only see the new changes in the last transaction. Okay, so a query reads subscription, just activate the subscription, setting the subscription sub-orders to active. The subscription is a multi-user, multi-machine approach, so any machine and user will have their own active subscriptions, and that makes it easy to actually see the last changes on, for instance, your iMac, and also request the last changes on another machine, for instance, a PC or a laptop. And if they have a local state cache in an FD table, they'll just work out. They'll just see the changes they haven't seen yet. Instead of seeing the changes on the database, they'll see the changes they haven't included yet. So that's a nice mechanism though. So that's why the set subscription has the iMac Danny. And there should also be a subscription with laptop Danny or desktop Danny, depending on how many machines you use to go to the database. Okay, I'm going to create a procedure to request the delta. Just added a query orders delta, which is just a select star from orders. I'm going to start the transaction. Okay, I'll just add the read subscription SQL text here again. So just to make sure that it's all in order and you can actually see what's happening in code as well. So what I'm doing here is setting the subscription sub-orders at a user. So that should probably be your machine plus your username or some unique identifier to active. So I'm using iMac Danny here. So that's unique for me for this connection. And as soon as I execute this subscription here, I am able to see the last changes between the last commit and activating this subscription. So if I execute the read orders delta, which is a select star from orders, I'll see only the last changes since the last commit with the subscription being active. So if any other user changes data and commits it, I'll be able to see that because that's not within my transaction, it's another one's transaction. Well, these existing changes, what I'm going to do is I'm going to merge them in the FD query orders. So suppose those are editable. I think I'm going to make them read-only, but well, just suppose that they're editable. So if there are updates pending, I need to apply those updates. And I'll be using cached updates, so that's why I'm using apply updates here. And then merge the read orders delta, merge the changes from other users into the query orders. So I'm going to use FD query orders, merge dataset. That's a built-in method in FireDAC that allows you to merge changes, inserts, updates, deletes into an existing dataset. And the query read orders delta only has the changed, the updated, or the inserted records. So I'm going to merge that data using the data merge. And if there are any changes in the meta data, well, I could just ignore it, but just put update here. That's okay. So I've merged these changes back into FD query orders. Now I need to mark these merged changes as being completed. And that basically means that I am going to commit my FD transaction delta. And hereby marking that I've read those changes up until now. So that's it. So I'm going to commit the updates from FD query orders in the FD query orders, mark them as completed, and also mark the transaction as being committed. Mark subscription, yeah, okay. So committing the query, and that's okay. So I'll just commit that. If you want more information about change views or Interbase change views, there are some nice videos by Stephen Boll. Stephen explains change views quite nicely, so take a look at those as well. I'm going to add a button here in the main form, and that button will just execute the refresh on the orders table using change views. The orders table is 1,000,000 records, but of course we only want to see the changes that are made by other users. So using change views here is very elegant and quite efficient as well, because any user that changes an order, if just a few orders, will only be requesting those few orders, that's all. And how does this work? Well, we just need to call into the data module main, into the get delta orders, and that's it. We've got a refresh. Okay, I'm just going to make sure that the DB grid here, the orders display, is actually read-only. You can only use the new and the edit and the refresh buttons here to actually, instead of using that one here, let's make it read-only here as well. Okay, so instead of using that one, we're going to use the buttons to make new orders or edit existing orders or refresh them. Okay, and in the form create, in the load data async, I need to make sure that we set cached updates to true. In a regular application, you'd probably use FD mem tables with a local state cache. I'm using FD cached updates, so I'm only caching the last state of the application starting from the start of the application, instead of persisting state over multiple startups of an application when using an FD mem table local cache. Okay, let's run this here and see how that works. It's still just as fast. It's now running in the background. It's requesting your orders. That's 1,000,000 orders. That's the first thing it's doing in the TTask. In the meantime, the user can just add customers and do other stuff that's available already in the application, because it's asynchronously loading your data in the background using a TTask. So I've been able to add 3 orders. Oh, well, 2 and 1 additional order. Customer Jim McKeith. Okay, let's see what's visible here. Yet another customer and CodeRage customer, but Jim McKeith not visible yet. So let's click refresh. And scroll down and you'll see Jim McKeith. So refreshing that only took a second instead of 20 seconds. And if I add another order, the new here is actually using a separate transaction, so it's not visible for the grid. It's not there. But if I refresh here, you'll see, yep, it's there. Subscriptions are good. So that's very fast actually. In a separate SQL statement, I could actually update a record. So let's do that in Interactive SQL. I'm going to update a single record as if I were a different application or a different user on a different location. So I'm going to update orders and I don't know, set the customer name to something else. So to changed by someone else. I'm using a key here. Let's see here. That's a globally unique identifier. Actually, using globally unique identifiers as a primary key, that's going to create an unbalanced primary key. For this application, I'm doing that because I'm actually adding data from multiple locations, and some of them don't have access to generators. So it's based on some production code. Okay. Hey, it's not here. Oh yeah, I forgot to commit the transaction. So I need to commit it here, and then refresh it, and then it should show up. And there it is, changed by someone else. Now, our default subscription will only show you the inserted and updated records. So let's also create a subscription that also shows you the deleted records, instead of only those updated and inserted ones. So I'm going to create a subscription on the table employee, and that one will also display the deleted ones. You can also use a column granularity if you want to, just describing to single columns. I'm not doing that here, I'm doing this for the entire row. So if for the entire row I want to see all inserts, updates and deletes. And if I add deletes to this here, it's going to be slightly more expensive, so this subscription will take a little more effort on the database side. Since it's using the transaction mechanism that's already embedded in Interbase and its versioning engine, it doesn't take all that much effort. So on the Interbase side of things, it's not just taking all that much effort. So it's okay to add multiple subscriptions to multiple tables. It'll work just fine. Okay, so now I've got 2, sub employee and sub orders. Sub employee being on update and delete, and sub orders only being insert and update. Subscriptions can survive over disconnects and reconnects. They're just based on the identifier that you give when you activate the subscription. So that's IMAC Danny in this case. Okay, thank you for listening in on this session on modernizing your VCL application. If you have any questions, please enter them in the chat window of your webinar software. And if you want to download the sources or the slides, please visit my website. The link is displayed in the Q&A page.